Here's a technique for evaluating limits algebraically. It's just using your algebra skills to simplify big fractions. I'm going to do this problem here two different ways. The way that I know I first learned how to do it and did for many years is just to, how do you simplify a big fraction like this? Well, oh, I almost forgot. First thing you should always try is plug the value in. So 1 minus 1, sorry, 1 divided by 1, whatever. This is indeed 0 divided by 0, so I have more work to do, okay? Uh, so I'm going to get a common denominator among those two. So this is a 1 over x minus x over x. Likewise, in the bottom, I'm going to get a common denominator of x squared. So this is 1 over x squared minus x squared over x squared. So this is the limit as x goes to 1 of, well, there's a 1 minus x over x on the top, and there's a 1 minus x squared over x squared on the bottom. Now, how do you divide? I'm just going to put this right here. How do you divide two fractions? This is the limit as x goes to 1. You got to flip the bottom one over and multiply, right? So I've got a 1 minus x over x, and I've got an x squared over 1 minus x squared. So, right, that division is just this way. Now I'm down to two layers, right? This is now the limit as x goes to 1. One of the x's cancels out. Everything's factored here. This times that, this times this. So I can cancel out one of those x's. So I've got an x times 1 minus x on the top, and I've got a 1 minus x squared on the bottom. That canceling out the x over x didn't get rid of my 0 over 0, right? Because x was going to 1. I still have a 0 here, and the bottom is still 0 when you plug a 1 in. So let's see if I can factor that thing now. I've got the limit as x goes to 1 of x times 1 minus x. And this does factor into 1 minus x times 1 plus x. And there, my 1 minus x's cancel out. That's my 0 divided by 0. Now I'm ready to try plugging the 1 back in. Plug a 1 in on the top, plug a 1 plus 1 in on the bottom, and the answer here is a half. All right, big fraction, simplified it. Let me show you another way that I do that. Same problem. Limit as x goes to 1. I got a 1 over x minus 1 and a 1 over x squared minus 1. That is, what I do is I'm going to multiply by 1. And the way I choose my 1 is I look at all the denominators involved, and I see an x and an x squared. The least common denominator of those, the least common denominator is x squared. So I'm going to multiply top and bottom by x squared. What happens is there's a distributive property. You've got to multiply this by both of those things. You've got to multiply this by both of those things. So here we go. The limit as x goes to 1. The x squared times this fraction, this x is going to cancel out with one of those x's, leaving just one x left on the top. The x squared times the 1 is just x squared. And then when I multiply this in here, the x squared times the 1 over x squared, well, both x's cancel out, leaving just a 1. And then the 1 times x squared here is just x squared. So this gets me to a two-layer fraction really pretty quickly. I make sure that I multiply by everything that I need to cancel out denominators. Right? Anyway, in this case, I've got to factor the top now. Limit as x goes to 1, I can factor an x out of that. So 1 minus x. Factor the bottom as a 1 minus x times 1 plus x. And we're back to where we were right here. Right? So those cancel out. And I've got a 1 over 1 plus 1 for my half. Okay, so let me try one more that's a little more complicated, but use that second method of doing it. So I want to take the limit as x goes to 4 of 1 over x minus 1 over 4 divided by 1 over x plus 1 minus 1 over 5. Right? If I plug the 4 in, this is 1/4 minus 1/4 on the top. It's 1/5 minus 1/5 on the bottom, which is my 0 divided by 0. That's my signal that, hey, there might be a limit. You got to do more, right? You got to do some more work. So what I'm going to do is I'm going to multiply top and bottom by all the denominators. I'm going to multiply top and bottom by 4, by 5, by x, and by x plus 1. This is in my way. Let me move it over here. All right. There we go. X plus 1. All the denominators I'm going to multiply by. 4, 5, x plus 1. Okay. Distributive property gets that into both of those, gets this into both of these. So when you multiply this by the first part here, the x's cancel out, leaving me 20 times x plus 1. The 20 is the 4 times 5, and the x plus 1 is left over. When I multiply by here, the 4's cancel out, so I've got 5 times x times x plus 1. When I multiply here, the x plus 1's cancel out. That just gives me a 20x. And lastly, when I multiply by this 1/5, the 5's cancel out, leaving me 4x times x plus 1. And there were minus signs in between here, so they're still there. And there we are. We're very quickly down to a 2-layer fraction. Now I'm going to have to see if I can collect some like terms here. So limit as x goes to 4. I'm going to multiply everything out here. So this is 20x plus 20 minus 5x squared minus, I just noticed something. I don't want to multiply that out. I could do that. I was going to multiply everything out and collect some like terms. But what I'm thinking is I really want this factored. So I'm going to erase that. And I'm going to say, look, I have a common factor of x plus 1 in both of those. Let me factor it out. What's left from the first one is a 20. What's left from the second one is a minus 5x. That was really cool. That just saved me a lot of work. Also, I noticed in the bottom there's a factor of x that I could pull out here. So that's x times 20 minus 4 times x plus 1. Well, that looks kind of funny. Well, let me multiply that out, I guess. Limit as x goes to 4 of, actually I see a factor of 5 in here too that I want to pull out. So I've got a 5, I've got an x plus 1, I've got a 4 minus x, and then I'm going to see what's going on in here. This is a 20 minus 4x minus 4. Right, as I distribute the minus 4 into both of those two things. Right. And the 20 and the minus 4 get together to be a 16. So I'm looking at the limit as x goes to 4 of 5 times x plus 1 times 4 minus x. And then I've got an x times, this is a 16 minus 4x. And I'm thinking, oh, we're in good shape because I can factor a 4 out of that. All right, so here we go. The limit as x goes to 4. I've got the 5, I've got the x plus 1, I've got the 4 minus x, I've got a 4 that I'm factoring out of here. There already was an x out there, so when I factor a 4 out of the 16, there's just a 4 left. When I factor the 4 out of the 4x, there's a x left, and there was a minus sign in between. And there it is. There's my 0 divided by 0, my 4 minus x over 4 minus x when x is going to 4, right? That's the 0 over 0. I just got it canceled out. So we're in good shape now. Plug the 4 in. I've got a 5, I've got a 4 plus 1, and I've got a 4 times 4 on the bottom for a grand total of 25 over 16. Right? I don't think there's any way that I could see ahead of time, looking at this, that the answer was going to be 25 over 16. But I just multiplied by 1 to cancel out all the denominators. Knowing that I'm trying to cancel, I'm looking to factor, and I happen to notice that I got a factor of x plus 1 on the top, factor of x on the bottom, that I could get this process out. If you didn't recognize that, it's still okay. Multiply it through. You get a big quadratic on the top, you get a big quadratic on the bottom, and then you just have to factor them. That's positive. That's still okay. And we get down here, finally cancel out the 0 over 0, plug that value of x in that you're approaching, 4, and see what you get for an answer. Okay. There you go, simplifying big fractions.